There is a sentence Richard Feynman is said to have used to describe death, and it is only 6 words long. Nothing ever truly disappears, only changes. It sounds almost too simple to matter. A throwaway line from a physicist who spent his life with equations most people will never read. But that sentence is not a comfort he invented to soften a hard truth. It is a description of a law that governs every atom in your body, every atom in the body of the person you lost, and every atom that will ever exist. The sentence is not poetry, it is physics. And the reason it changes everything is that it forces a question almost no one asks out loud. If nothing ever truly disappears, then where exactly did the person you loved go? To understand why that question has a real answer, you have to begin with something measured, not something believed. In the 19th century, a series of careful experiments established what is now called the conservation of energy and the conservation of mass. The work runs from James Prescott Joule in England to Hermann von Helmholtz in Germany, and it was refined for more than 100 years afterward in laboratories around the world. What they found was not a theory in the loose sense. It is one of the most tested statements in all of science. Energy is never created and never destroyed. It only moves from one form into another. Matter is never erased. It is only rearranged. This is clinically confirmed in the strictest sense the word allows. Not plausible. Not likely. Measured again and again in every controlled experiment ever designed to break it. Nothing has ever broken it, and it applies without exception to a falling stone, to a burning candle, and to a human body. The atoms that made up the person you loved did not stop existing on the day they died. They could not have. The law does not permit it. Every carbon atom, every atom of oxygen and calcium and iron that was assembled into the shape of a person you knew by name is still here, still in the world, still subject to the same conservation that has never once failed. There is a reason this is so hard to feel, even after you understand it, and the reason is in your own neurology. Research led by the neuroscientist Mary Frances O'Connor at the University of Arizona has shown that the human brain does not encode an absent person as gone. It encodes them as elsewhere, as temporarily out of reach, the way someone is out of reach when they have stepped into another room. The brain holds an internal map of the people we are bonded to, built over years of contact, and that map does not update simply because the heart has stopped. It continues to predict the person's return. This is why grief feels like a mistake the world has made, rather than a fact you can absorb. Your neural model insists the person still exists somewhere and will come back. And here is the quiet collision at the centre of all this. The physics agrees with the brain on the first half and breaks with it on the second. The matter does still exist. The moments do hold their place. But the arrangement, the living pattern your brain keeps predicting, is the one thing the laws do not preserve. Now follow the mechanism, because the mechanism is where the comfort and the grief live together in the same place. A human body is, by mass, mostly water, somewhere near 60% of it. The rest is built from a small set of elements, arranged into staggering complexity. Oxygen, carbon, hydrogen, and nitrogen account for the overwhelming majority of what you are. Then calcium and phosphorus, holding the skeleton together. Then traces of potassium, sulfur, sodium, iron, and a handful of others, each one playing a precise role in a system more intricate than any machine humans have ever built. That is the inventory. That is what a person is made of, at the level the conservation laws care about. When a body dies, the arrangement begins to come apart, but the elements themselves are conserved at every single step. This is the part worth slowing down for, because it is where intuition fails us. We feel in grief that something has been annihilated, that a person has been removed from the sum total of things that exist. The chemistry says otherwise, and it says it without exception. The carbon returns to soil and air, and eventually to other living things, the same carbon that has cycled through every living creature that ever existed. The water rejoins the cycle that moves it through rivers and clouds and rain, water that has been on this planet for billions of years and will be here long after. The calcium that gave structure to bone persists in the ground for a very long time. The iron that carried oxygen through the blood, atom by atom, was forged in dying stars before the Earth existed, and it does not stop existing now. Not 1 gram of any of it is subtracted from the universe. The total is exactly what it was the day before. The shape is gone, The substance is not. The bookkeeping of the cosmos is perfect, and it never writes anything off. Think about what that actually means at the scale of a single atom. An atom of carbon that spent decades inside the person you loved, that was part of a hand you held or a voice you heard, does not carry a label that says whose it was, but it persists with the same indifference to your loss that it had before they were born. It will go on to be part of a plant, then perhaps an animal, then perhaps the air you breathe. It was on loan to the arrangement we called a person, and the loan has been recalled, but the atom itself was never spent. This is not sentiment. It is the dullest, most reliable accounting in all of nature. Mass in equals mass out. The universe has never once been caught losing track. And here is the distinction that the 6-word sentence is built on, the one that decides whether it consoles you or wounds you. Gone from arrangement and gone from existence are not the same thing. The physics is precise about which one death is. Death is the loss of arrangement. It is the dissolution of a particular, irreplaceable pattern. But the matter that held the pattern is conserved completely. That is not a metaphor a grieving person tells themselves at night. That is what the conservation laws say, and they have never been observed to say anything else. I want to be careful here, because there is a kind of false comfort that physics does not actually offer, and it would be dishonest to hand it to you. The conservation of atoms is real, but the atoms do not carry the person. They carried the person in a specific configuration for a specific span of time, and that configuration is what made them who they were. So the law gives you something true and something hard at once. The substance remains, the arrangement does not, and the thing you are grieving is the arrangement. This is why the sentence changes everything without ending anything. It does not return the person. It tells you precisely what was lost and what was not. Stay with that for a moment, because there is a companion to everything this channel explores, something I've spent months assembling called What Feynman Knew About Grief, and the link to it is in the pinned comment below. Stay with me though, because the part that most people find hardest to believe is still ahead. What happens to the way you understand time when you take the second half of Feynman's worldview seriously? For that, we have to leave conservation and turn to relativity, because this is where a physicist's view of death stops resembling anyone else's. In 1905, and then more completely in 1915, Albert Einstein established that time is not the universal, flowing river we experience it to be. Time is a dimension, woven together with the 3 dimensions of space into a single structure that physicists call space-time. This is not speculation. It has been confirmed by measurements so precise that the satellites used for navigation must correct for it constantly. If they did not account for the way time runs differently at altitude, the entire system would drift into uselessness within a day. The relativity of time is clinically confirmed every second by machines in orbit above your head. And inside that structure, something strange and specific is true. In the mathematics of space-time, the past does not vanish. Physicists describe it with a model sometimes called the block universe. And while interpretations differ, the equations themselves do not treat the past as deleted. They treat every moment as a fixed location in the structure. A coordinate, the afternoon you are thinking of right now, the sound of a voice, the particular light in a particular room, occupies a permanent address in space-time. It is not erased by the fact that you have moved away from it. You have simply moved forward along the dimension of time, the way you might walk away from a city that continues to exist behind you. The reason this is more than a philosopher's word game comes from how relativity treats the present itself. In Einstein's framework, there is no single universal now that sweeps across the entire universe at once. 2 observers moving differently can disagree about whether 2 distant events happened at the same time, and both of them are correct. There is no privileged moment that the cosmos agrees to call the present. And if there is no universal present, then the sharp line we draw between what exists, the now, and what no longer exists, the past, loses the firm ground we assumed it stood on. The distinction between then and now, which feels like the most obvious fact in the world, turns out to depend entirely on where you are and how you are moving. To the equations, the past moment and the present moment have the same kind of reality. Both are simply locations. This is the conclusion that physicists themselves have drawn from it, and it is worth knowing they drew it in exactly the context we are discussing. When Einstein's lifelong friend Michel Besso died, Einstein wrote to Besso's family He told them that for those who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. He was not offering an empty consolation. He was telling them what his own physics had forced him to conclude. The moment of a person's life is not extinguished by the arrival of later moments. It holds its position. It keeps its coordinate. The river of time that seems to carry everything away and dissolve it is, in the mathematics, not a river at all. It is a landscape, and we are the ones moving through it. This is where the medico-philosophical line has to be drawn honestly. And I will draw it. The conservation of matter is settled physics. The block universe is a serious and widely discussed interpretation of relativity, but it is an interpretation, not a measured fact. So I will say it the way a careful person should, that the past is permanently recorded in the structure of space-time is mechanistically plausible within the most successful theory of physics we possess. It is not confirmed in the way conservation is confirmed. But it is not fantasy either. It is what the mathematics, taken at its word, appears to describe. And what it appears to describe is this: the moments you shared with the person you lost are not gone in the way your grief insists they are. They are not behind you in the sense of having been destroyed. They are behind you in the sense of being elsewhere along a dimension you can only travel in one direction. The person is gone from reach. The physics does not say they are gone from the structure. Those are two different sentences, and the difference between them is the entire distance between despair and something quieter. What this means together, conservation and relativity, is that Feynman's 6 words are doing two things at once. Nothing ever truly disappears, only changes. The matter is conserved in space. The moments are fixed in time. Neither the substance of the person nor the reality of the time you spent with them has been subtracted from the universe. What has changed is only your position relative to both. You have moved forward in time, away from the coordinates where they still are. And the matter that was once arranged into them has moved into new arrangements you cannot recognize. Change, not disappearance. That is the whole of it. There is a guide that follows this thread all the way through, the companion called What Feynman Knew About Grief, and it is in the pinned comment below only while this video is up, because what we are circling now is the reason this particular physicist is the right person to be hearing this from. Feynman did not learn this the way the rest of us learn physics, as a set of clean abstractions on a page. He learned it twice, once with chalk and once with his whole life. In June of 1945, while he was at Los Alamos working on the most consequential physics of the century, his wife Arlene died of tuberculosis. They had been together since they were teenagers. He had married her knowing she was dying. He arrived at the hospital that day after she was already gone, and then this man, who understood the conservation of matter and the structure of space-time more deeply than almost anyone alive, who could have recited every law I have just described, went home and continued to live inside his grief like any other human being. 16 months later, he sat down and wrote her a letter. He told her he loved her. He told her he wanted to take care of her, that he wanted to do small things for her, that he found himself unable to understand why she was not there to receive any of it. He wrote it to a woman who had been dead for more than a year. And then he never mailed it. He kept it. It was found in his papers 43 years later, after his own death, and it ends with a line that holds the entire paradox in one breath. Please excuse my not mailing this, but I don't know your new address. That is the man who said nothing ever truly disappears, only changes. He knew the laws, he knew the matter was conserved, knew the moments were fixed in the structure, knew everything I have just told you with a fluency the rest of us can only borrow. And it did not make the writing of that letter unnecessary. It did not let him skip the grief on the strength of an equation. He understood better than anyone that the conservation of atoms does not deliver a voice back to you, and that a coordinate in space-time cannot answer when you speak to it. He wrote the letter anyway, to an address that no longer existed in the only frame of reference that hurt. So the sentence does not change everything by ending grief. That was never what it offered. It changes everything by telling you the exact shape of what you are grieving and the exact shape of what remains. The person is not in reach. The substance of them was not destroyed. The time you had was not deleted from the universe. You have only moved, and they have only changed. And both of those are true at once, and neither one cancels the other. The physics gives you no permission to stop missing them. It only tells you that the universe did not throw them away. It does not lose things. it rearranges them, and it keeps every coordinate it ever made. Before this video ends, I want to say something directly to you. Thank you. You are the reason this channel exists. YouTube removed our ad monetization, and even after that, they continue running ads on these videos, collecting that revenue while we receive nothing. We tried to remove those ads so they wouldn't interrupt you. The machine kept them running. So we made what Feynman knew about grief, not as a business move, but as a way to keep this reaching people without depending on a system working against us. If what you found here mattered, the link is in the description and pinned in the comments, only while this video is up. He wrote the letter, anyway, to an address he could not find. We keep making these anyway, into a structure that does not erase what we put into it. Nothing ever truly disappears, only changes, including perhaps this, including perhaps the part of you that is still listening for an address you can no longer reach.